Now, the next topic we will talk about is one of the basic pillars of every programming language, namely variables. Now, everybody knows variables from math. However, in programming, they work slightly different, and I'll try to help you understand the difference between math variables and programming variables. Now, in programming, variables are nothing else than ordinary containers or boxes. At least that's how I want you to imagine them. A variable is a container for a value. So I can open this variable and I can put some value in there. Now, whenever I use the variable x, the computer takes this container, looks what is inside, and uses then the value inside. And that's a fundamental difference compared to how variables in math work. Because you see, in math, a variable is the same as a value, just kind of another label on it. However, in computer programming, those are two fundamentally different things. This is a value, this is a number, and this is just a place where you can put numbers into. That's an important distinction, and if you get this right, it will help you in your programming journey ahead. Now, variables are used everywhere. Whenever you see an object in a game, I can almost guarantee you it has got variables in it. So examples would be you have a player and the player has hit points. Hit points is a variable of the player. Movement speed would also be a variable of the player. Jump height might be a variable of the player. The damage it deals, and so on. The list is endless. The score of your game, the duration you've been playing, all of those things are usually stored in variables. So it's really the basic building block of every program that we're going to write. Now, on the hardware side of things, I want you to realize that every variable that you create is space that is reserved for your value. Now, where is this space reserved? On your random access memory. So on your RAM, you need to reserve some space where you can then put this value into. That's what variables are on the metal of your computer. Now, if that was already it, it would be too easy, wouldn't it? Now, in order to make things a little bit harder, the developers of many programming languages decided that we also need something called data types. And a data type describes what can be stored in a certain variable. You see, the computer distinguishes between different variable types. For example, a number is stored completely differently than a text. And every variable has a certain data type assigned to it. And the data type describes what kind of value can go into this variable. Now, for the next part, I will become kind of a physics professor for you. At least that's how I feel. So in order to drive this point home, I've prepared a little experiment for you. Now, we want to look at data types and variables. So I have prepared two variables for you. I have here one variable, and here I have another variable. And remember, variables are just containers for values. So let's put them up here. Okay. And now let's save some values into those containers. So firstly, I have this value here. It's a loaf of bread. And let's save it. Now let's try something else. Now I also have some water. And let's try to save the water in the glass. And this too works fine because you know what glass is made to hold water, right? So the data type matches. In this case, the data type of the glass would be water, so it matches and we can store water in there. The same goes for this bowl here. We can put a loaf of bread in there and it fits in perfectly well without any problems. So up until now, everything is nice. However, now let's see what happens when the data type of the container, in this case the glass, doesn't match the data type of the value we want to store in this case the loaf of bread. So if I try to store the loaf of bread in the glass, it doesn't fit in, you know? We won't be able to put it in there, no matter how hard we try or how we arrange it. The glass simply isn't made to store this loaf of bread. And that's what we could call a data type mismatch. Right, so let me just put this away. Now let's see what happens when we take this bread container and put some water value in it. Well, who would have thought? It doesn't work either. So maybe I should have thought this through.
A few moments later.
So I think we all learned something here today. Firstly, always make sure the data type of your values match the data type of your variables. And second, be careful when you work with water next to your computer, because I really underestimated how much water splash there's gonna be. Now let's conclude this lesson with the 5 data types that you will use every day of your life as a game programmer and that you need to know by heart. First, integer or int. Integer saves whole numbers, so those are 5, 10, 17, minus 13, and so on. So most numbers except for comma values. Now the second data type is the float. Float stands for floating point, and this is used for storing comma values like 17.3 or 413.45. This is the float data type. Third, we have the char or character. Now a character stores a single character, as the name implies. So examples would be A, B, F, C, G, whatever, yeah? But also numbers stored as character, like 7 or 3. Now, there is an important distinction. The computer distinguishes between an integer number 3 and a character 3. The character 3 is interpreted as text, and the integer 3 is interpreted as a number. So you can calculate with the integer, but you can't calculate with a character, for example. Next, and this is an important one, is the string. Now, you could imagine it as a string of characters. So multiple characters after one another. And if you put multiple characters after one another, you get a word. So strings are used to store text. That's basically what they are used for. And lastly, the last important data type that you need to store is a Boolean. Now the Boolean just stores true or false. And that's already it. Also pretty handy as a programmer, as you can imagine. Now in the next lesson, we will look a little bit deeper into each one of those data types and have a look at how they can be created in Visual Studio.